All right, so what does it take to use the substitution method in this case? Well, let's recap the problem once again. Don't forget we have two types of alcohol solution, 35% and 65%. We don't know the exact number of gallons we need from each, but we want to make exactly 24 gallons of alcohol with the concentration of 45%. Okay, and notice that the questions at the end ask how many gallons of each you need. Because you don't know how many gallons, right away you should define a variable, or two, in this case 2, to represent your unknown value. So you can use A or B, but I'm just going to use X and Y anyway. So X here represents the number of gallons of the 35% type, okay? And Y here represents the number of gallons, just make it short, of the 65%. Okay, so we have that clearly defined, we have something to work with. Then if you read the problem carefully, you see that if I want the two types to be added together, I have exactly 24 gallons. So therefore, I can certainly come up with my first equation, and that simply is going to be x plus y equals to 24. And to verify that this is indeed valid, look at this. Isn't x gallon? Isn't y also gallons? Gallon plus gallon should equals to gallons, right? If you have a different unit, you know that you've gone off somewhere. That's not correct. Okay, so gallon, gallon, gallon. Second equation, though, since we're done with gallons, you know that we have to deal with the concentration level. And the concentration level is measured by how many gallons you have and what type of concentration it is. In this case, I know I have X number of gallons of 35% concentration, and to convert the percent into an equation, you have to write it as a decimal. So we write it as 3500ths, or 0.35. Of what? Of X, because we define that, right? Same thing for Y, it's going to be 6500ths of Y, and what does it equal to? I want to make what? I want to make 24 gallons of 45% concentration. So here's the 45 concentration, and I want to make 24 gallons of it, right? That's the total combined of the two. All right, so we clear things up here, and as you can see, we end up with what over here? I hate decimals, as you can see, right? So let's clear it first. If we clear the decimal, we have to multiply the whole thing by what? By 100. So that's going to give you 35x plus 65y, and this comes out to be what again? 10,080? 1,080, right? 1,080. Okay, so the decimals is gone, so I don't need this equation anymore. All I have to do is just use the red equation right here, x plus y equals 24, and the bottom equation. At this stage, it's already lined up. I can use elimination, but because I want to show you the substitution method, we can actually do that also. To do the substitution method, I would always go with the easiest equation because I need to make sure I can solve for a variable. Okay, so I look at the easiest equation to solve for, and the easiest one happens to be the x plus y equals 24. I just need to pick a variable. Which one would I solve for? Pick one.
X.
Let's say, okay, fine, y. If I say y, that means I'm going to find another name for y. What is y? If I want to solve for y, that means y is what? How do I solve for y? You subtract the x over, right? So it's going to be 24 minus x. So that means every time I address y, I also means 24 minus x. Is that true? Or 24 minus x is y. That's what you need to understand. This is how we set up our substitution. If you cannot have a different name for your variable, you cannot use substitution. So now I have a name for the y. That means every time I see the y, I replace the y with what? 24 minus x. So if I write my entire equation again, it's going to be 35x plus 65. This is the part that y will get replaced, and it's going to be 24 minus x equals to 1080. Question on that part. This is the crucial step for substitution. And then, of course, you see this right here. You would definitely distribute. You have 35 times x plus, what is 65 times 24 again? What is that number? Huh? 1560? Is that it? 1,560. Minus 65x equals to 1080, right? Agree? Anyone disagree with that? Well, cool. Okay, so then notice we have like terms of x. We combine them together. What's 35x minus 65x? Negative 30x. Okay, so negative 30x plus 1560 equals to 1080. And then we would try to go ahead and solve for x by, oh, I missed a number here. Subtract the 1560 over. You got negative 30x equals to, what's the answer here? Negative 520, you said? Is it correct?
No.
No.
Negative 4.
Negative 420, you said. Negative 420?
Negative 480.
Negative 480. We agree?
Yeah.
Yes. And at this point, let's divide by negative 30. X equals to 16 gallons, right? Of what? Oh, 16 gallons of the 35% type. And I know I need to make 24, so all I have to do is plug 16 back into here and solve for it, and I kind of do it in my head too. 16 plus what is 24? 8. So that's how we got our 8. So this is called substitution. What do you think of that? Same exact step, right? You saw Jennifer showing us the elimination method technique, and substitution will work out the same way. It's to your liking, really. If you love substitution, you want to stick with substitution all the time, sure. But sometimes it's actually easier to use elimination over substitution, so you might want to pick and choose. Okay, question there. And yes, you can also use your GeoGebra to verify your answers, yes.
How do you get 1080?
How do you get 1080? Well, from here.
Yeah.
0.45 or 4500 times 24 will give you 10.8. And because I want to clear the decimal, and the longest one is in the hundredths place, I multiply everything by 100. That's how I got 1080. Okay. All right. So before I give you your next problem, I need to show you something, and it's important that you know this. Yesterday, I showed you 3 different scenarios of lines, right? First scenario is where you have 2 lines crossing over at one point, 1 intersection, 1 solution. What is that called again? Consistent independence. And you have 2 parallel lines, meaning no solution because they would never cross over each other. What is that called? Inconsistent. And you have the third case where you have 1 line on top of the other one, so they're overlapped at every single point. How many solutions do you expect to have there? All solutions. So you can technically pick any point on that line, and that will be your candidate for your solution. And what do we call that? Consistent dependent. Okay, great. Now, I want you to look at this right here. I'm just curious, okay? If I have a system equation like that, and I want to ask you to solve, which method would you use to solve that one? You only have 2, substitution or elimination. Which one would you pick? Why? Yeah, substitution you have to solve for a variable, and you expect to see fractions, right? But with eliminations, why is it good for elimination right now? What do you notice? Is it already ready to go? Yes? Yes, it's all lined up already. Notice everything is lined up. As long as you have everything lined up, good for substitution. Okay? And so, with substitution, which variable column would you like to get rid of? Y or X? Does it matter?
No.
It doesn't. Okay, so if you love Y, let's pick Y. Here is the Y. Remember that for us to get rid of that column, we have to find what? LCM. So this is the important key right here. If you cannot have the LCM, you can't get rid of that column yet. So what is the LCM for 3 and 5? Notice I ignored the sign completely right now. 15. So I know that my LCM is 15. That's my target number. How do I make the top 15? Times it by? 5. Okay. How do I make the bottom 15? Notice that this is not 15 yet. Times it by 3. Okay. So if I times it, this is what I will see. 10x plus 15y equals to 35, right? What about my bottom equation? What is it going to look like? 21x minus 15y equals to 24. Now I'm still targeting the y column. Now here's my trick question. how do I get rid of the y column? What operation would you use? Okay, see? Notice that you are so used to subtracting and you think that every single case will involve subtraction. But think about this. If you were to subtract the column, 15y minus negative 15y, will you get rid of the y? So let's write it out. 15y minus negative 15y. Will you get rid of it? You see that? So you got to be careful when you choose your operation. You have to choose the operation that will get rid of your column, not making it more or less. Okay? So the only thing now, or at least if you notice that every time you see opposite signs, what operation do you use to get rid of them? Addition. And if you see the same number, same sign, you would use subtraction. And that's the pattern. So in this case, I'll be using addition, addition, addition throughout the problem. And I would have 31x equals to, this is already gone, and 35 plus 24 is?
59.
59. And I would go ahead and divide by 31 both sides. And x is 59 over 31. Okay, and if I need to solve for y, I just take what x is, substitute it right back into any equation, and solve for y, and it will get you the answers. I know that would be a bit complex, but that's how it's done. Okay, and the reason I had to show you this problem because I want you to see, just in case you have different LCM, you would be multiplying into both, and just in case you have different signs, you will be adding them to get rid of them. Okay, any question there? Okay. With that, I'm just going to go and